Welcome back. And in this lecture, we witness a major intellectual turning point the moment humans realize life doesn't just appear out of nowhere. This is a downfall of spontaneous generation, a belief that dominated for over 2000 years. Imagine that a single scientific mythic surviving from Aristotle all the way to the mid 1800s. Today, we meet scientists who finally killed that idea. But before that, Um, I actually would like to talk about this painting. This is an experiment on a bird in the air pump by Joseph Wright of Derby, 1768, which one of the paintings I really like. You can see the dark room illuminated by the single lantern, the scientist figure, or a showman looking scientist figure, displaying an experiment. The effects of the vacuum on this bird, showing that they need oxygen to survive. And if you look at the room, scientists looking directly to us, even asking, should I let the bird live or die? And these children here, they are scared, but you can also see they are enlightened, light directly on them, so they are learning, but it scares them as well, which reminds me of the story of Adam and Eve, because when they become conscious, when they learn stuff and get the information from the apple, they find out that they are naked and they were frightened. So it's very similar and really interesting. You can also see the young couple here. They don't, they barely notice what's happening. They are flirting. For them, the experiment is part of the atmosphere, like a background music. It's showing that scientific culture become part of everyday social life as well. It's a really beautiful painting, and I always really like this one. Let's move on. So, spontaneous generation, what is it? For most of human history, people truly believe that life just appeared out of nowhere. Like maggots appeared from rotting meat, mice appeared from piles of grain, and fleas emerged from dust. And microbes, the smallest unknown agents, were said to arise from nothing at all. This idea for dominant for 2000 years. It's ridiculous for this time. Nobody had microscope, nobody knew about bacteria. Decay looked like magical transformation. If you leave meat out, maggots will appear. That's exactly what you observe. And of course, Aristotle approved the idea. In the ancient world, if Aristotle said something, you didn't question it. There was like medieval recipes for how to create a mice. There was something like placing sweaty underwear and wheat of jar for 21 days and you will get your mice. This sounds absurd, really absurd now, but it was sincere science at the time. So, why it was believed for 2000 years? There were four main reasons it lasted that long because no knowledge of microorganisms. If you can't see a bacteria, you can't imagine them. And there's a rapid decay, food spoils quickly, and tiny organisms appear in it even quicker. Lack of controlled experiments, nobody sealed containers properly or sterilized equipment, and there's always the Aristotle authority. He believed in vital heat, a natural force that transformed nothing things into living ones, and this became doctrine for centuries. To defeat spontaneous generation, scientists had to fight against both nature's illusion and philosophical traditions and these authority figures. And let's start with one of them, who is Francesco Redi. The first experimental attack we can call came from Redi. Sorry. Redi was an Italian physician, poet, and even surprisingly, the personal doctor of three Tuscan Grand Dukes. He adored nature and hated sloppy reasoning. He thought if maggots come from meat and not flies, then they should appear even when the meat is sealed. So he sets up an experiment, one of the first truly controlled biological experiment. There is a first jar. We will see them in the second page, maybe. Yeah. There's the first jar with open meat and there's maggots. There's a second jar, a sealed meat, and there is no maggots. And the third jar, it's gauze covered jar. Flies lay eggs on the gauze. Maggots grow on the gauze, not on the meat. This was very genius at the time. He didn't just say Aristotle was wrong, he proved it. Where he showed that living organisms come from living organisms. It sounds obvious now, but in 1668 this was revolutionary. However, this experiment only killed spontaneous generation for maggots and not for the tiny invisible world nobody yet knew existed. And if we continue, there's a second figure of Spallanzani. He made the broad experiments. So, he is a priest, a naturalist, long distance runner, and a legendary experimenter. He's one of those Renaissance figures who seemed good at everything. In 1765, he boils nutrient broth to kill microbes, as you can see. He boils them. Sorry. He seals the flask here, and the result there is no microbial growth. But if he left it open, eventually there is a growth. So this was a direct attack on the idea that microorganisms spontaneously arise. But critics, mainly vitalists, argued and responded, no, 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 no. You killed the life force by sealing the containers. Life needs that air. They argued that sealing prevented the vital principle in the air from entering the broth. So Spallanzani proved contamination came from the outside, but he couldn't silence the life force believers. And the debate continued. And Spallanzani was actually had one more really interesting experiment on his shoulders. He was so obsessed with animal reproduction that he once dressed frogs in tiny pants called frog trousers to test whether fertilization required physical contact. So they were really creative back then with their science. So during this time at 19th century, science really changes. As you can see, there's a geology arising and chemistry. There's a molecular understanding coming. Of course, you know the Lavoisier on that, and also from the geological standpoint, there's Scottish Enlightenment, which we will discuss shorter, and also Darwin will came into picture in this time, and there are first questions about naturally occurring life, but much more realistically, and we will continue with Louis Pasteur. He is the basically a titan, a chemist, biologist, a myth destroyer, I would like to call. His famous experiment is elegant and almost poetic. He designs a swan neck flask. The flask is open to air, and air can enter. And dust and microbes get trapped in the curved neck, and the broth remains sterile. And tilt the flask, dust enters, and microbes grow instantly. This experiment was devastatingly conclusive. For the first time, scientists saw life does not spontaneously generate. Microbes come from other microbes. No life force, no magical essence, just biology following the natural rules. So when Pasteur presented this to French Academy of Science, he said, "Never will the doctrine of spontaneous generation recover from the mortal blow of this simple experiment." And he was right. Actually, um, he has a very long legacy of things. He created the germ theory, enabled sterilization and hygiene. Actually, the doctors back then didn't know the infection and why the so many patients are dying. And Pasteur teach them that if you clean your instrument in boiled water, no one dies. So he introduced hygiene and invented pasteurization, inspired the birth of modern microbiology, and he helped create vaccines as well. And he reinforced the mechanistic view of life. He was a really extraordinary, very extraordinary man. He also talked about the chirality at that time, which is incredible for a scientist back then. So Pasteur shifts biology permanently. Life is not magic, there is no vital force, and chemistry and physics obeying laws, and that's all. Very, very interesting. So before continuing, oh, this is a very beautiful, beautiful painting I would like to talk about. This is Burns' first meeting with Scots. This painting is depiction of the Scottish Enlightenment and very important. I believe it's hanging in the Edinburgh University currently. So there's a meeting in Edinburgh at Hill House between two giants of literature, Robert Burns and Scottish poet Walter Scott, which is just a very child looking here. They make meetings with all these Enlightenment researchers at the time. So Scott here is just a teenage admirer, and this is one of the rare moments in history where talent and future greatness collide in a single living room setting. So Burns Strand or sits in a relaxed, almost humble posture, becoming, despite being the famous poet, and Scott is young and not yet author who will one day define historical fiction. Around them, members of the literary circle of Edinburgh, powerful intellectuals alone, they make conferences academically. It's a very beautiful, beautiful painting. They actually created the modern geology as well as Scottish Enlightenment with um, has many, many, many developments at its gates. It's very, very, very beautiful. But let's continue to our subject, vitalism and its fall. So without spontaneous generation, and vitalism becomes very unnecessary. So scientists become to believe that life is a chemical process and organic molecules are not magical. Life can be studied in laboratories, maybe even created in laboratories. This sets the stage for the origin of life experiments for the 20th century. And if you continue on that, we're gonna meet the Frederick Wöhler, which is really, really important. In 1828, before Pasteur even published the Swan Neck work, another revolution occurred from Frederick Wöhler. He synthesized urea, an organic molecule, from just inorganic compounds. This was the moment chemistry punched vitalism in the face. Wöhler was not trying to destroy a philosophy, he was simply exploring the reactions, but his discovery proved you can make organic molecules without life. After this, the idea that some molecules belong as special living category collapsed and they become the same. So Wöhler wrote to his mentor, who was Berzelius, I can make urea without needing a kidney. And Berzelius was a believer in vitalism, was horrified by this result. Let's continue to evolution. So while I was making the page, it became like even a movie poster, and I didn't want it to ruin it, so I left it like this. But we will continue with more pictures here. So um, I would like to talk about the evolution. So let's. I think we should start with Jean-Baptiste Lamarck, the first current theory of evolution. Lamarck is remembered for being wrong, but that's really unfair in his point. He was first to attempt a mechanistic explanation of how species change. Before him, most people thought species were fixed, created once, and unchanged forever. Lamarck proposed two key ideas: use and disuse. Organs strengthen When used and weakens when not used. Inheritance acquired traits. Animals pass on these changes to their offspring. So he believed giraffes stretched their necks and passed on longer necks to their young. Now, scientifically, we know this mechanism doesn't work in the way he imagined, but it was evolutionary. But also, evolution itself and our understanding are still evolving with epigenetics, where the environmental factors will affect our genes and how we inherit them. So maybe he is not too wrong, maybe after all. So environment shapes life is the point where it's become essential when we think about the potential life in Mars, Europa, or Titan, or any exoplanets as well. And if you go through Darwin, um, so while he was 22-year-old, a university dropout and unsure of his career, in 1831, he went on this HMS Beagle and sets out what was supposed to be a 2-year survey voyage. It became a 5-year odyssey and changed the world. So he brought 17 notebooks and filled them with observations, sketches, fossils, and measurement. And he saw geological events, earthquakes, lifting lands, volcanoes, reshaping islands, and realized Earth was dynamic. He collected fossils of extinct animals in South America and compared them to similar living species. The Galapagos Island became his natural laboratory. Finches, tortoises, mockingbirds, all slightly different from island to island. So he didn't have that theory instantly. The Beagle didn't give him evolution neatly packed, but it planted questions that haunted him for decades. If One of the questions he asked himself, if Earth can create so many diverse species through natural processes, then life on other worlds, if it exists, may also follow a natural evolutionary pathway. And this is a bridge from evolutionary biology to astrobiology. So, evolution by natural selection. Darwin shows complexity can arise naturally. Adaptation does not require divine guidance, and biology follows gradual processes. This shifts philosophical atmosphere. If species evolve without divine intervention, maybe life itself could originate through natural processes too. Darwin even speculates about a warm little pond where life might have begun. But let's continue on the other side of the science, where we meet a story about the Mars Canals era. So Mars Canals. So while microbiologists killing vitalism and zoologists are providing the evolutionary background, astronomers were accidentally resurrecting cosmic fantasies. In 1877, Giovanni Schiaparelli observes Mars and draw straight lines, calling them canali, meaning channels. In English, this is misinterpreted as canals, suggesting artificial structures built by intelligent beings on Earth. As you can see, these are the channels here. Where, and later, we're going to introduce Percival Lowell. So, he was one of the most enthusiastic canal believers in history. He built an entire observatory to study Mars, and he published books claiming Mars is drying and dying civilization built canals. They are moving water from the poles to the equator, and by that the public goes wild. Even scientists are intrigued. Lowell was wrong, very, very wrong, but his mistake fueled interest in planetary life for decades. A fact that H. G. Wells wrote The War of the Worlds, inspired partly by Lowell's Mars theories. So science fiction owes him a huge debt, but we also see the limited data and the maximal imagination still going on at this stage with Martian canals and how from the poles they channel the water to reach the equator because it was drying out and Martians were needing water. We also now know that those were ancient roots of water, so they're still that, let's continue. So, there's also another very important Dutch painting of education, study, and university. Important, and um, this is from Rembrandt, the anatomy lesson of Dr. Nicolaas Toep, painted in 16th century, 1600s. It captures a real event public dissection performed by Dr. Toep here, a city anatomist in Amsterdam. So the dissections were allowed only once a year, and they were treated almost like lectures mixed with theater. People bought tickets. It was an intellectual performance. So there are surgeons around them, learning, watching with curiosity and fascination. And this was one of the first where it wasn't actually allowed, but one of the rare piece of art which Rembrandt drew. But let's go back to our topic, why this all matter for astrobiology. So these breakthroughs through Redi to Pasteur and Wöhler to Darwin create a foundation for modern origin of life research. We now know life doesn't appear magically. We know microbes come from microbes. We know organic molecules can be synthesized. We know biological complexity can evolve. And we know planets may have conditions for life. Only with spontaneous generation gone could scientists begin asking the real questions. If life doesn't arise magically, how does it arise? And that question leads directly to chemical evolution, the RNA world, hydrothermal vents, and protocells, and every modern experiment in abiogenesis and astrobiology. So that concludes lecture 4. And in next lecture, we move to chemical evolution and more interesting figures like Operon, Miller and Urey experiments and early Earth conditions and true beginnings of the origin of life theories and astrobiology. And thank you for joining me, and I'll see you in lecture 5.